So, we were looking at how to calculate either the H3O plus or the OH minus concentrations given one or the other. Simply take the Kw value and then divide it by the given value. And then you can determine the unknown. In this case, the unknown was the H3O plus. So you took 1 times 10 power negative 14 divided by the given value for OH minus, which was 5 times 10 power negative 8, right? So then you just plug it in into your calculator, and so the H3O plus value comes out to be 2 times 10 power negative 7. Now this is greater than 1 times 10 power negative 7. Therefore, this solution is acidic. Okay, so here in the study check it says if lemon juice has an H3O plus of 2 times 10 power negative 3, what is the OH minus? So just take 1 times 10 power negative 14 and divide it by this number, 2 times 10 power negative 3. Okay. All right. So when you do that, you should get the answer, and I believe it should be C. Yeah. So 2 times 10 power negative 3 on the denominator, 1 times 10 power negative 14 in the numerator. All right. Okay. And another way to do it by inspection, which is what I was trying to do, is if 14 minus 3, right, that would be 11. But 1 by 2, that's half. And if you move the decimal point one spot, 0.5, then it becomes 5. All right. So then you multiply, you multiplied it 0.5 by 10, and then therefore that 11 becomes 12. But anyway, if it's too complicated, just plug it in into your calculator and it'll give you the answer. Okay. So C is the answer. All right, section 11.6 deals with the pH scale. Now, dealing with all these exponential numbers becomes tedious and laborious, and it's hard to keep it all straight, all right? Whereas pH is a very easy scale because it's in whole numbers. It goes from 0 to 14, all right? So pH of 7, that's neutral. pH less than 7 is acidic. pH greater than 7 is basic, all right? So it simplifies. It takes this exponential numbers and converts it into a whole number, okay? So if pH is 7, neutral, all right, that means H3O plus is 1 times 10 power negative 7. When H3O plus is greater than 1 times 10 power negative 7, then the pH is less than 7. When the H3O plus is less than 1 times 10 power negative 7, then the pH is greater than 7, all right? So that's basic, okay? Less than 7, acidic. 7 is neutral, okay? pH can be measured using a pH paper. You can, yeah, I mean, litmus is good enough to tell you what's acid and what's base, but you can take something which is colored dye paper and then compare it to set given numbers. Or else you can do it most accurately with a pH meter, because what it does is it is basically taking the conductivity, so to speak, electrical units, and converting it into a number, a numeric value. All right, okay. So it's very accurate. The pH meter is very accurate. So here you have cabbage. Cabbage juice is also a good indicator, right? So you prepare the cabbage juice and add it to different kinds of buffers that range from 0 to 14. So each one has a different color, all right? Usually the acid colors are the pinks and the deep magentas. And then the base colors are usually here in the greens and yellows, okay? And then, or else you can take those pH papers and then compare it with the chart given on that on this thing here, and then you can then use that to get those numbers, pH numbers, or you can use a pH meter which directly gives you the pH number. All right, so here's a listing of different things, that common everyday things that we encounter. Some food, some cleaners, some shampoos, and everyday use things, all right, food and other stuff. And as you can see, most of the foods are acidic, all right? There's a reason for it. If it was basic, it would taste pretty bad, okay? Because most basic foods are kind of have that bitter chalkiness to them, all right? So, for example, that little bit of bitterness that you experience in coffee, okay? Or there are very, very few foods which are basic or alkaline, okay? Most of the cleaners, though, seem to be alkaline, okay? Okay, and as you know, antacids have that chalkiness to them, okay? So that's a base, okay? All right, identify each solution as acidic, basic, or neutral. So HCl, pH 1.5, of course, acidic. Pancreatic fluid, H3O plus, 1 times 10 power negative 8. So this is a pH of 8. So it's obviously basic, or H3O plus is less than 1 times 10 power negative 7. So therefore it's basic. Sprite, pH 3, acidic. pH 7 is neutral. OH minus is 3 times 10 power negative 10. Okay. So OH minus is much less than 1 times 10 power negative 7, right? So this solution has to be acidic. H3O plus is 5 times 10 power negative 12. All right, so 10 power negative 12, much less than 10 power negative 7. So therefore, this is basic, okay? So acid, base, acid, neutral, acid, and base. Okay, so what exactly is pH? pH is defined as the negative logarithm, log to the base 10, of the H3O plus concentration, all right? So that's the exact definition. So the P, the lowercase p in chemistry, stands for this negative log of. The H stands for the H3O plus concentration, all right? So you can have pKw, which would be the negative log of Kw, or you can have pOH, which would then be the negative log of OH minus, all right? So that P means negative log. Why did they bring this in? Because then they can take something which is an exponent number and convert it into a whole number. So if you take the negative log of 1 times 10 power negative 2, it's basically you're converting it into that, the numeric value of that exponent, all right, into a whole number 2, okay? That's why they brought in pH, or this word P, okay? All right, so if you have, how do you determine sig figs in pH, okay? If that H3O plus concentration has 2 sig figs, okay, then your pH will have 1 extra sig fig, okay? So if it has 2 sig figs total, then the pH must have 2 sig figs after its decimal point, a total of 3 sig figs in the pH value. Okay, if it just has 1 sig fig, then the pH will have a total of 2 sig fig or 1 sig fig after its decimal point. Alright, so if the pH is 2, the H3O plus is 1 times 10 power negative 2. pH is 3. That coefficient, if it is 1, then the pH is basically whatever that numeric value of the coefficient, alright? So, and the numeric value of the exponent, sorry, alright? So as long as the coefficient in the H3O plus is 1, then you don't even have to plug it into your calculator. It's just going to be the exponent value, alright? So 1 times 10 power negative 2, that's 2. 1 times 10 power negative 3, pH 3. 1 times 10 power negative 4, that's pH 4, and so on, okay? So as you can see, as the H3O plus concentration is increasing, the pH is dropping, okay? Which means it's getting more acidic. When the pH drops, it gets more acidic. Alright, how do you interpret these this pH scale? If you look at these circles as representing a concentration of 10 to the negative 4 molar, all right, moles per liter of hydrogen ions, right? Then 10 to the negative 3 is going to be 10 times that, right? So a pH drop in 1 unit means that the decrease in this H3O plus concentration is by a factor of 10, all right? So pH drop of 2 units, that means it's 10 times 10, a pH increase in H3O plus concentration by a factor of 100, okay? So from 4 to 3, 1 unit drop, it's H3O plus increases by a factor of 10. 2 unit drops, H3O plus increases by a factor of 100. Okay. All right. So when you're doing pH problems, if the H3O plus is given, then just take the negative log of this and you get pH. Okay. If you, and also make sure that the sig figs match up properly according to the rules of sig fig for pH. Okay, so H3O plus is given 1.7 times 10 power negative 3. So just plug it into the formula. Take the negative log of 1.7 times 10 power negative 3. All right. Now you see here, this is 3, right? If the coefficient was 1, the pH would have been 3, but it's 1.7. So therefore, the pH should be in the ballpark of 2 point something, okay? And it is. So if you plug that in, it comes out to be a long number, but you remember the rules of sig fig. So in the H3O plus, you had 2 sig figs in the coefficient, therefore you will record your pH to 2 sig figs after the decimal point, so you'll record it as 2.77. Alright, so here the H3O plus in the study check was 4 times 10 power negative 5. Again, put that into the formula for pH, and again the pH should be, because the coefficient here is 4, it should be 4 point something, the answer, okay, and it is 4.40. Again, coefficient 2 sig figs after the decimal point, okay, and that's it. All right, we'll stop here.